Welcome everyone to the PoE Lighting and Automation Bootcamp. We're really excited to have our participants live here in Austin, as well as our participants who are coming in through Zoom. So we're trying to do both today. I'm the CEO, Tyler Andrews, and I will be walking you through the presentation today, and then I'll be turning you over either to Joshua on Zoom or to Joe, our CTO, who's going to be hosting the training session live today. What we're going to be covering are the principal steps to train you how to design, project manage, program, and commission a PoE lighting system. We're going to go through the fundamentals of what you need to know if you're going to be tackling a full automation system, whether it's a small project like we're going to do together today, whether you're going big for some of you who are trying to do like a resort. I will share for you today that the training is going to be focused on PoE products, but we are a member of what's called the PoE Consortium, and that's the consortium of the top 7 PoE lighting and automation manufacturers around the world. And we will be using PoE Texas equipment, but ideally, much of what we're talking about today will translate to any manufacturer. So I'm going to try and keep as much of it open as possible. Obviously, when we get to a certain level, you have to do it based on a manufacturer's product, and we're going to be doing ours today. So let's start talking about the fundamentals of PoE lighting and automation. So these are the basic concepts that I'll be talking through today, and I will cover each one of these in turn. The real basics that we want to cover and make sure we talk about are what's an automation system and what are some of the key components you need to know about in an automation system. So I'm going to dive right in to a PoE switch. So with PoE switches, when you're doing lighting and automation, it is not the same PoE switch that you would use for, say, a PoE camera. You really need to understand some key items around power, both the power by port and the total power budget. And there's some key considerations about the installation location that help drive both the selection of the form factor and the power. So today, I actually have some products here with me. So an important feature about PoE lighting is you need to make sure you go with an 802.3 802.3 BT, ideally type 4 PoE switch. What a type 4 PoE switch does is it gives you a power budget of 72 watts at the port at minimum. That's kind of the industry standard. If you don't get 72 watts out of that port, you're not actually using an industry standard switch. Now, having said that, there are differences in 802.3 BT type PoE switches because not all of them will really do what a lighting system needs. And what that is there's a little bit of a power fluctuation. What we found, some products and some manufacturers don't quite get to the power they need to do before the detection system shuts off that PoE port. So if you've ever, I'm sure you guys have seen a PoE port, if you try and draw too much power, drops off the port. Because of the nature of the lighting and type BT type PoE, you have to make sure you use a PoE switch that is reputable and good for that type of power. Now, there's also another element that has to do with that you need to know about. There are a lot of manufacturers that have a forced 90-watt PoE setting, and that's how they handle PoE lighting. I'll give you some manufacturers, really good manufacturers. Transition Networks, who have transitioned to a new name, I can't remember right off the top of my head. Lantronix, that's it, Lantronix. Lantronix switches, you do need to learn how to set the power setting to forced 90-watt PoE for certain PoE lighting manufacturers. Cisco is very good. We found the Cisco switches power up very well, but your performance may vary. So I'm going to encourage you. Our switches are specifically designed for PoE lighting. They're designed so that you don't change any of the settings. You plug it in and it's going to work full load. But if you're not familiar with the manufacturer and you're trying out a new switch, give it a test. So that's the per port power and the note on that forced or not forced. There's also a question of the total power budget or power groups. Different manufacturers group their power or have a different power budget for the switch. And that's a really important thing to know, because you could say, and I'll pull up our 24-port switch, you could say to yourself, hey, I'm getting a 24-port switch. I can plan on plugging a PoE light into every port on that 24-port switch. PoE switches have a total power budget that sometimes doesn't match having 90 watt per port on every port. And what that means is, as you're, and we'll go through this in the planning, you'll want to make sure that you're picking your equipment based on the total power budget you need. Now, I can tell you for PoE Texas, this guy is designed for 2,160 watts of power. It will do 90 watts per port, all 24 ports with our power supply. A little note here, ours comes with a DC connector. We actually have a separate power supply, and that power supply is got a front loaded power packs that you can pull out the front that'll do 3,000 watts. And that's something we chose. And you get to see that we're playing with that here in the office today. But pick your power, make sure you're getting enough power on your switches. That's an important item to note. And then the other big thing to note too, and for example, we have at least two form factors. This form factor is obviously a 1U rack mounted form factor. For those of you guys who are watching at home or in the office. That's a 1U one. You'll want to put this into obviously a rack. This guy is DC powered and it doesn't have separate fans, but the power supply that's rack mounted that pairs with it does have a fan. And as you're sitting here, you can probably hear it in the background. If you're putting this in a hotel room, you don't want to put that in a room where, like a hotel room or a guest room or in somebody's office where they can hear those fans running. People complain about fans. So you would put that type of device into a server room, an IDF room, or an IDF cabinet that's enclosed, or an MDF that is, behind a door, so you don't hear that. The other alternative that you could do is, and by the way, this guy does need to have good ventilation. With these higher powered PoE switches, you don't want to bury them in a hot box because they are handling a lot of power. So good ventilation is important. We do specify in our documents, what wattage you get out of this guy in terms of heat rise. You need to make sure you note that, and that is actually one of the requirements you present. We'll talk about that a little bit later. There is also this 8-port switch. Now, this 8-port switch is specifically designed to be in a hot environment. So this could go in a ceiling box or an unventilated box. And it's got 8 ports and it's 2 fiber ports in. So, and it as well is designed for 90 watts on all 8 ports. So you get 720 watts out of it. But you need to think about where you want to put your switch. And you may have thought, oh, I'm just gonna put it in the server room and I have to have a big server room. You can do a distributed network with a device like this, or you could have a centralized network with a device like this. So those are some of your considerations that you're thinking about in terms of your PoE switch. Next, there's something that the industry term most people use is a PoE node. We call that product, our branded on it is called a link. And we call it that because we call it the local intelligent network controller. The considerations you need to know are how many and what type of, how many inputs and outputs you have, and what type of wiring you have to have with it. And I'll point out, this is considered an off light node. You don't have to have it baked into the light. You can choose a lighting manufacturer who will put, some lighting manufacturers and some PoE controls manufacturers will put the node Whether they call it a node or not, or whether you have an RJ45 port on the back of the light, they would call that, and they would still be a node inside. Either way, you have some smarts that is doing something to control the lights. This guy is actually a replacement for, it ends up being a replacement for the AC to DC LED driver. And that's an important knowledge. And in fact, I can pass this around for you guys here, but for the use of those of you who are at home, this is UL certified specifically to replace the LED driver on an AC light fixture without voiding that UL certificate on that light fixture. The reason why we picked that is because we chose an off fixture node, so that you could pair this with a whole wide range of light fixtures. And that's a really important distinction, is you could tell your local code official, hey, I'm going to tear the AC driver out of this light fixture. And he goes, well, that voids that UL certificate. No, this is UL certified to replace AC drivers. And then all nodes have so many inputs and so many outputs. If it's baked into the light fixture, then obviously there's one output, that light fixture. And sometimes they'll have like another port on there that might be like an RJ11, sometimes they're RJ45 ports. Our product, we specifically designed it to go with a wiring harness. So this is both something you'll see in terms of how you wire it, as well as what it can do. So you'll see this port on the front here. It's a 20-pin jack that's designed to go with our wiring harness. We always sell with the wiring harness. Don't worry, like if you're worried, we're going to sell you a link and you're going to get it and it's not going to have a wiring harness. You're going to go, what the hell am I supposed to do with this? We always make sure we sell it with a wiring harness, and we can always send additional wiring harnesses. Our link, this model, is designed specifically to have 4 outputs, and the outputs can either be constant current or constant voltage. And then our inputs are either 4 universal inputs. So these are the outputs, and then we have 4 universal inputs. They are 24 volt. We can do 24 volt DC on off signal, dry contact on off, or 0 to 10 volt on these. So you can pick which kind of input you'd like. So Jeremy, I see you've raised your hand. I'm going to let Jeremy, I'm going to pause here and let Jeremy ask his question. Hey, Jeremy, do you want to ask your question, or do you want to put it in the chat?
Yeah, no, I'll ask the question. It was a comment and a question. The comment is, as an online attendee, I'm deeply disappointed to learn that I'm not going to get to try Texas's second best barbecue.
Sorry, Jeremy, I wish.
I'll have to live with that for the rest of my life, but that decision. No, my question was just when you were speaking about switches and now with the PoE nodes, I wasn't clear on, does each switch port power a single light, or does each switch port power multiple lights, and is that through these nodes?
So that's a great question. Jeremy is asking, does each PoE port power one light fixture or one light node? So Jeremy, great question. The PoE port powers one node every time. You power one node, and depending on the manufacturer, that one node may be just one light fixture. For PoE Texas, it is 4 outputs. And what can you do with 4 outputs? If, just as a rule of thumb, our 4 outputs can drive, you can drive as few as 2 light fixtures if you're going with 2 large 2x4s. And then depending on the configuration, you can go up to somewhere around 10 fixtures. So you don't have to assume one PoE port equals one PoE light. For example, something like this, you could use one node and you can wire up an entire room. For example, this room that we're in, it has 2 overhead lights. Those 2 overhead lights are running on one node? So that's a great question, Jeremy. Thank you. So 4 outputs gives you the option to do, for example, if you're looking at the screen right now on the wiring, you can see I have 2 outputs used on one fixture. Those 2 outputs would be a warm, cool light fixture where I want to change the color temperature. Excuse me. And you will be doing that in your class today, both on Zoom and live. You're going to be playing with the 2-channel color changing light fixture. Another note though, Jeremy, too, if I'm doing an RGBW fixture, I would use up all 4 of those channels: red, green, blue, and white. Your 4 channels are on one node. So it depends on the configuration. Excellent. So thank you, Jeremy. Appreciate the question. So keep raising hands as you guys have questions. We're doing really well. I will bring in I'll point out one other thing. All nodes, including our link, have an identifier, a unique identifier to help you associate it, because part of the controls process will be to associate one device with one space or one room or one light fixture. So all nodes have to have a unique identifier. In our case, we've chosen to go with a MAC address. We like the MAC address because it's easily read by all networking equipment, and it's part of our discovery process. So that's the MAC address is our marking, but all manufacturers will have their unique identifier. So let's move on to, make sure I'm on the right page, the PoE gateway. So a PoE gateway, and I'm going to show ours here. This is called the Core Tap Lite. A PoE gateway ends up being the brains of the operation. This is where you do your programming. This is where you do your configuring. This is where you do your rooming, like if you want to make rooms and spaces and groups. It is on this. There are a few manufacturers that will do this, but like will offer you one option where the node and the gateway are combined. Our options are to keep it separate, and we'll talk about why. We call this the considerations you need to, by the way, sorry, going back, the considerations you need to have on this is function, what it actually does in terms of a function, like what it serves, and I'll talk about what that means in a second. Single versus multiple, and where you're going to put this. So function, we call our gateway a core tap, technology access point. The function we use with this is, and other manufacturers have similar functions, we use the tap as a way to communicate between multiple technologies. So not just PoE, our gateway can handle N-Ocean, Bluetooth, Z-Wave, DMX, Dolly. It can be a multi-platform that puts all that onto the network for you. Other manufacturers offer different connections. Some of them do RS-485. Some of them will do USB. We can do USB as well through our gateway, but that is a choice as you think about the functions. What other systems do you want to talk to? A big one for us that we do is N-Ocean. If you haven't used N-Ocean before, wireless and battery-free controls. And then you need to think about where you want to put this. We have put ours in this little metal form factor so that it can be installed anywhere and used almost like a WAP, a Wi-Fi access point. You don't have to have it just back in the server room. And some manufacturers do. They're like, hey, you're going to put this on a server rack. It's going to be a server computer. Ours are mobile and can run about, basically. And because of that, we've also designed these to allow you to have multiple gateways on one network, and they will work together, or they can work as a distributed network. What that means is practically, I can buy 2 of these. I can have one as hot swappable, so you can have one running duty and the other on standby. If one of these ever dies, you push a button and whoop, it flips it over and you're running on the other one. You can also have a distributed network where all within the same network, I have this is, for example, floor 1, and I have a separate one for floor 2 and a separate one for floor 3. So the gateway or the core tap is the kind of the brains of the operation. Gary's got a question.
Is there a practical limit to the number of devices in one so that you would go to the second one?
Yes, so the question is there, for those of you on Zoom, is there a practical limit to the number of devices a gateway can handle? We tell you typically if you're going over about 3,000 devices, you'll probably want to do a distributed network. Different manufacturers have different standards, but for us, it's between 2,000 and 3,000. We've found very few people ever get close to that limit before they decide they want to have redundancy or they want to have a distributed network. Because at 3,000 devices, you're talking like a couple floors, like a whole building runs on something like this.
Okay, can I give a follow-up real quick?
Yeah, Gary's got one more question.
Okay, so if I were to do that on a per floor basis, I had 5 MDUs on a floor.
Yep.
Would I be able to protect the individual users, their equipment from, because they're common? Or
Yes.
is it better to put one in each MDU?
So the question is could we have these distributed and have them isolated so that you don't get crosstalk between one MDU and another MDU? Yes, they naturally create a local network for themselves. And what you would do as an administrator, you could go in and link globally to say the data point here is either available globally or I want to talk globally, but everything you don't put as global, it stays just on this device. Good questions. And with you guys at home on Zoom or in the office, raise your hand. I'll keep looking at the, I'll keep looking, but thank you guys for asking great questions. All right, Joshua, I think we got some questions. Yep.
Yes, I've been answering them as they come in.
Fantastic. Thank you.
Yep.
So let's talk about PoE enabled and ready light fixtures. We talked briefly about the question of integrated versus separate driver. And that's where you take either a node and you bake it into the light fixture, or do you have your node separate from the light fixture? In our case, we've opted to have a separate node from the light fixture. What that means for you as you speak to the manufacturer is that you ask the manufacturer either to send it without the AC to DC driver, or you send it with you just buy it off the shelf with the expectation that you're going to disconnect the wires from their LEDs, their supplied LED driver, and connect it to your intelligent node. You do need to find out some information from the manufacturer. That's really important. Whether the light fixture is constant current or constant voltage. And you'll hear us talk about that a lot, constant current versus constant voltage. Constant current is your most common commercial white LED fixture. For example, this one that I'm holding up, it's a 4-inch gimbal light. This is a constant current light fixture. Either warm white or cool light, or you can have sometimes warm light and cool light. And so I would say if you're doing if you're buying commercial light fixtures, you're probably going to see this about 90% of the time. Unless you're looking at color changing light fixtures. If you're going with an RGBW light fixture, it is much more common for an RGB light fixture to be constant voltage. And the other one that you'll find is a lower cost, kind of the low end brand for voltage, or some of the light bulbs will be constant voltage as well. The advantages for constant current and constant voltage are, if you're constant current, you have a little bit better range on how long your cable between the node and the light can be, because we're driving current and this driver can drive it, you can be, and this is an important note, if you're separate like this, you can have the node somewhere between 200 and 300 feet from the fixture, especially if it's constant current. You're going to get better performance and you get better dimming. So keeping in mind, like a little metric, I can have 330 feet from the back of the RJ45 port back to the switch. And with a constant current fixture, I could do something like 250, 300 feet with just 18.2, because we went with an 18.2 wire, so you can run a multi-conductor 18.2. So you can locate, for example, some people will take their node and they'll locate it in a box. If I'm taking, for example, a hotel room or an office room, they'll put all the nodes outside the room so maintenance can access them without having to access the room, and then just wire 18.2 to all the LED light fixtures. Just because they want to be able to get in there and maybe identify or mark up, and that's an option that you could do. And you could have it outside the office. That's constant current. Constant voltage has the advantage of more channels or more colors with fewer wires. So if I did an RGBW, you would have one 24-volt wire and 4 colors, as opposed to if you did constant current, you'd have to have a plus for one channel, plus and a minus for one channel, plus and a minus for the other channel, plus and a minus for all the channels. And then constant voltage is often a little bit cheaper, just because they mass produce them and you don't have to tie it to a specific LED driver. So they've got their pros and their cons. We do both. In our setup, the way you identify whether the link will do both as is, but the way you identify the difference is there's this little loop, and that tells you it's constant voltage. If there's no loop, it's a constant current wiring harness. And we make it easy if you guys wanted to swap it out. It's not hard to handle. And then I'll show you guys this at home. We do little wire stubs because we found electricians and technicians are most comfortable doing wiring rather than trying to do a screw terminal. And we found we like these little Wago 221s and 220s, and I'll pass that around if you guys want to take a look at that. So you can see those, they're handy. We're going to use those in the lab today. So we'll play with those in the lab today. And Wago, we were just at NECA, and Wago has a whole bunch of new, very cool options for these now. You can DIN rail mount them, you can put them in a line. It's a very handy tool. All right, but I'm going to pause here. These are the main components of a PoE lighting system. Do you guys have any questions either on Zoom or here? So Gary's going to ask a question. If you're at home or Zoom, go ahead and raise your hand and I'll come to you and I'll answer any questions about the main components.
So on the constant voltage for dimming, is it a pulse width dimming?
Yes.
So it's not like trying to get it down to 12 volts to dim it. It's just the amount of on time versus off time.
Well, you use the on time versus, so Gary's asking if it's pulse width modulation that we use on constant voltage to adjust the dimming. It is, you use pulse width modulation, but you'll see is in the settings, if we do a constant voltage, the frequency of our pulse width modulation is high enough that you're never going to see it with your eye, but you use that to adjust the voltage down. It's rare that you find anybody who doesn't do pulse width modulation anymore in terms of voltage control, just because it with your FETs and other technologies, analog adjustment of voltage just it's less efficient.
Yeah.
That's a great question.
That's a good answer.
Yeah. All right. I will keep moving on. Keep asking your questions. I know Joshua was looking at the questions online. So now let's talk about a little bit, and then we're going to move on to our practical example. The key components of an automation system. All automation systems have to have inputs. And I see, Joshua, you've raised your hands. Do you want to ask a question, buddy?
Yeah, I wanted to share a question here from Peter, if you wanted to open up the Q&A there. So okay. Peter's asking if the links can read any sensor data.
Great question. So Peter on Zoom has asked if the link can read any sensor data. The link can handle any sensor that has either a dry contact on and off a 24 volt DC on and off, or 0 to 10 volts on and off. The link does not currently do 4 to 20 milliamp signals. And then I'm trying to think if there are other sensor types, like analog sensor types that are out there. Dry contact, 24 volt DC, and 0 to 10 volt, and 4 to 20 milliamp are the most common ones. And then Peter, if we don't read it, like if it's not an analog signal, that's what the core tap is for. We interface directly to the core tap. We have wireless sensors and ocean sensors, Bluetooth sensors, those types of sensors that transmit their data that way. That would talk to a core tap rather than a link. And yes, the core tap takes a whole wide range of sensor types, especially if it's on the network. If it's on the network, it's an easy integration for us to bring it on. Gunshot detectors, microphones like SIP microphones, those types of products, easy to add to our product database. Great question. Thank you, Peter. So key components, all automated systems have to have inputs. And we just talked about those, whether they're light levels, whether they're 24 volts, you have to have some type of input that controls the system. And without an input, nothing happens. And then you have to have what Joe likes to call a stimulus or an output. That's where the output actually does something. And our control system is set up that way, where you set up inputs, you set up outputs, and then you use what we call a logic binder, some functionality to tie an input to an output in whatever grouping that you want. And sometimes, by the way, those inputs and outputs can be virtual. And that's very cool. We're going to actually do that today in our training. You're going to create a virtual button that only exists on a computer screen, but acts as if it was a button that you're pushing. All right. Let us dive now into our practical example. So for those of you who have your workbook in front of you, flip to the first page, and I emailed out everybody who's participating this PDF file called a design workbook. The first page looks like this, and I'll get to that in just a second. So you're doing a project, right? You've been awarded a project, or you're an owner and you're executing a project, and you're going to be doing a PoE lighting job. Let's talk about the different activities you need to plan to do at different phases. So this is the design phase. Whether you're early on in the design or you're well progressed in the design, there should be a few key things you're going to want to have before you finish your design as an installer. The three main things are and our workbook has very simplified versions of these. The three main things are going to be a reflected ceiling plan, and that's typically in the architectural design set. A device schedule, that can sometimes appear in the electrical set of drawings. It could also appear in what we are starting to call an operational technology set, or it might even appear in the architectural set. And we'll talk about each one of those in turn. And then ideally, you're going to get a controls narrative. If you're not given a controls narrative, you're going to need to come up with a controls narrative, because that's how you're going to program the system. Without a controls narrative, even if it's a very basic, very simple one, you need to have some controls narrative. So I've given out this as a very simple floor plan, and I'll describe it. Take notes and think about it, and note what you notice briefly in the design. And I'm going to turn on my little pen here so I can draw. Some things you'll notice is you'll see this little funny A here. And then you'll see these little symbols that appear to be lights. And then there's a B here. So what you're noticing is this is actually a light fixture shown on the reflected ceiling pan. And it is fixture type A. This is another fixture, which will be a fixture type B. This little M here is a very common way of indicating a motion detector. And then for those of you who are on Zoom and watching today, yes, this does mean you just won $4. Just kidding. This is that dollar sign is an indicator of a switch, and it is a four-way switch. And then the D I'm using to indicate a wall controller. I've added all of these onto this design because you're going to be playing with most of these. You'll also notice one other key item. You should have a room identifier. Room identifiers are important. Sorry, I just crossed it out, but room identifiers are really important for your purposes of identifying and planning. So always get rooms identified on your drawings. So let's go here. So that's our floor plan. We have our reflected ceiling plan. Hooray! The next thing I have is a very simplified lighting and device schedule. I'll give you a warning here. I'm comprehensive. Everything on the reflected ceiling plan, I added as a device on the device schedule. You're not guaranteed to get a device schedule. Sometimes you'll have to check the specifications. For example, they may throw in only in the specifications that every light fixture is a motion detecting light fixture, which you can do. They sell light fixtures that have a little motion detector built in. They may throw other things like you're going to do light level detection in the specifications. It doesn't appear on the device schedule. So don't take it as gospel. You'll find everything nicely baked into a device schedule. I did it for our purposes today to help you see what kinds of things you would normally see on a device schedule. On the left-hand side, you'll definitely see the, get a little pen here. You'll definitely see the device identifier. This should correspond to what you'll see on the reflected ceiling plan. You'll see that that A corresponds to the A and the B. And what you do then is you could look at the reflected ceiling plan and see fixture A, and then come here to this device schedule and see fixture A is a 4-inch color tuning gibbled down fixture, white. It will often give you the selections in terms of color, size, orientation. It should also give you a manufacturer's part number, so you can reference that part number. It'll often give you the quantity, the power, and the budgeted power for that. Most good schedules will have the power, not all of them, but it's a good, most of them do at this point. What you can see from this is these are all PoE Texas part numbers. I will put in our little plug here. PoE Texas does supply everything from the PoE switch to the light switch and everything in between, including lights, light switches, controls. You can get it all with PoE Texas, but you don't have to. What you'll notice about this indication here is we do a very good job identifying that power. You're going to need that power. Most all of this information you see on this table, you're going to need at some point in your part of the in the process. Now, I've also given a very simplified controls narrative. Controls narratives can be very complex, and they can be very arduous, or they can be fairly simple. What I've documented here will basically be what you will do in the training lab. So as you're doing the lab and you're looking at the notes and you're like, what am I really trying to achieve? This will guide you through it. You'll notice that I broke it down based on basically inputs and what inputs will do to outputs. What we talked about is, the 4-button switch. There's a top, a second, a third, and a fourth button, what they'll each do in turn. I talk about what the motion detector will do when you have different scenarios. And then I talk about the customized wall controller. You will be making your own digital custom wall controller today. So that's good news. So I'll pause here. Anybody want to ask any questions about these 3 things, your reflected ceiling plan, your device schedule, and your controls narrative? All right, because now I'm going to start asking questions. So this is your time now. I've reproduced the reflected ceiling plan. This is your time now to consider how you would start doing your design. And this feels very much like what you would do if you gotten a design or if Joe gets a design from us. So the question is, how many links or nodes would you need for this space? And I want you to go ahead and use the paper. If you're at home, mark up your PDF How many links would you need for the space? Feel free to draw them in if you want to try and draw where they'll go. This is an open book test, so don't worry, you can flip and ask questions. Keeping in mind, I have the considerations there that a link has 4 inputs and 4 outputs. So keep that in mind. The link has a total power budget of 80 watts. And a quick note here, fixture A requires 2 outputs because it is a color tuning light fixture. That means if of those 4 outputs on a link, 2 of them are used up with 1 light fixture. So you can't do all 4 of those A fixtures on 1 link. You're going to want to have 2. Yeah, you get 2 channels. So one of the ways I'll draw it here on my screen so you guys could see how I might do it. I'll drop a link in, like you could drop a link in on the left side and the right side. You could drop a link in, on the top and bottom, and then you would run 1 pair of 18.2 to this fixture, 1 pair of 18.2 to that fixture, 1 pair of 18.2 to this fixture, or sorry, I say 18.2, these would be 18.4. So I would run an 18.4 to each one of those because they have 2 constant current channels. So you get those 2 there. So you would, I've already got 2 links for those guys. I might throw in another link right here. I'll pull out my little drawing shape. I might put another link here, and that way I can take an 18.2 over to this light fixture. So working together, my count, I get a count of at least 3 links. Does that match up with your?
That's a salesman solution.
That's a salesman solution.
Well,
Great question.
Based on your sequence, you turn all the lights up and down together.
I do turn them all up and down together, but keep in mind that this light fixture, which is fixture A, requires 2 channels on a link. Oh, and this is a good note. Gary's asking a good note. Can I run constant current light fixtures in series? Yes. And the answer is maybe. Here's the trick. Constant light, these light fixtures, if I'm running constant current through constant current light fixtures, unless all of the light fixtures are exactly the same, one might burn slightly warmer or be slightly brighter or slightly dimmer than the others. And that's a little bit hard to tell when you do it. We don't recommend, that's a good question. We don't recommend running more than, we don't recommend running any constant current light fixtures in series. We definitely don't recommend running more than 2 in series if you really feel like you got to do that.
I was going to use constant voltage, but it doesn't.
So Gary's asking, could he do this in constant voltage? And that's a good question. If these are constant voltage fixtures, yes.
So
if
I would have 1 zone for A.
Yep.
Or 2 zones, 1 for the color and 1 for the other, and then I've got the track line here.
Yeah, so Gary is saying I would do 2 zones with a constant current or a constant voltage light fixture. So if you were working with a constant voltage light fixture, you could operate it that way. Now the downside is if you went that way, A would not be color tuning anymore.
Really?
Yeah, you can't get color tuning unless you have 2 channels.
Right.
So you would still have to use channel. That's a good point. If you could find a constant voltage 2-channel light fixture, you could do that. That's a good way. That's a good point.
These are good questions.
Yeah, these are good considerations. Yeah. So that is why choosing the right light fixture and understanding the light fixture can have some really big impacts. Is it constant current or is it constant voltage? Now, then the next question is, I'm going to assume I'm going to go with 3 links because I am the salesman and I'm going to do my sales thing. So let's go to the next page. You should be at either 2 or 3 links. Let me see if I can get this guy to read now. There we go. Now, once I've done my link count, and I'll throw my links back up on this page so you can see it. I put a link here. I put a link here. And I put a link here. The next one is based on the drawings, what other devices are in the system besides the lights and the light switch? So we do need to run a multi-conductor wire over, oops. I'm going to undo that one. We do need to plan a multi-conductor that would go, say, from this node to this light switch. And it's going to have at least 5 or maybe 6 wires in it, because you're going to have a common button 1, 2, 3, 4, and then our light fixture has a light in it, so you may have up to 6. I also have this motion detector, so that's probably going to be 2 input wires I run to that motion detector. I also need to plan a PoE drop for my wall controller, because the wall controller will be PoE powered. And then we also need our handy dandy gateway. You don't have to install the gateway in this room. I'm just making sure we don't forget to add a gateway to the planning, because there's nothing worse than going out to a job site and not even having a gateway controller. So you need to plan on a gateway controller, which means there's an Easter egg somewhere in here, and I'm going to see who catches my Easter egg. So based on that, we can live on 3 links with those different wires running to each of the different elements, or we could decide to go down to 2 if, like Gary is saying, you can get constant voltage fixtures. Does anybody want to pause me here and ask any questions so far? Gary's got a good question.
Real quick. So if I had more than 4, I could split those up to any links.
If you had more than 4, yes.
Yeah, I mean, you could programmably
Yes.
assign them, even if they're used somewhere else. I can get them to the closest link that has ports.
Yes. So let's say you had like an 8-button switch. What you would do then is you would take 4 of those inputs to one link, and you could take the 4 other buttons to another link, and then you'll be able to, in software, associate those buttons with whatever you want. You don't have to feel like, that's the great thing about PoE. You don't have to feel like just because I'm not wired to the same link, I can't make an association. You can make all those associations you want in the software. Software doesn't care. And that's a really powerful tool that Gary is pointing out. That's a great point.
And your motion sensor could apply to anything.
Exactly.
Once it gets into the closest links.
Yes, just because you've wired, and that is another excellent point that Gary is pointing out. Let's say I put my link here, and I have wired up my this to that light fixture, and I wired up to this motion sensor. You are not bound to only control devices that are on the link. So that motion sensor, you don't have to say, oh, well, that motion sensor will only control that light. Once that motion sensor is on the network, I can still control fixture A with that motion sensor, even if I'm not physically wired to it. And that's one of the most powerful features of a network-based or PoE light fixture. I can use software to associate that motion detector with any of these lights or all of these lights. Frankly, what's really cool about it is I can change that based on a schedule. I can say it's set at 8 o'clock in the morning, all the motion sensors are disabled and the lights come on. And it doesn't matter how many times that motion sensor sees or doesn't see somebody, it stays on. And then I could say at 6 o'clock, time to turn the motion sensors on. Now the motion sensor will control the lights. So because that's very powerful, you can associate and disassociate and use the software to do all of that. That's a really good point, Gary. Thank you for pointing that out. All right. So now this is where you're going to also help me complete this. you're going to take your device schedule. I added the device schedule at the top, and you're going to start taking basically your PoEs and control schedule and creating a schedule of devices practical to what you're doing. So the top one is just a copy of the previous schedule. This middle one here is basically where you're starting your notes for how you would design and implement the system. And let me talk through it. So I'm saying on the left-hand side, column 1, let me get my little, my spotlighter tool. Column 1 is room. So you know this is in room 100. It's easy with you got one room. But if you have like 10 rooms, you'd say 100, 110, 111. Then you also you list out the type of fixtures. So I know this is A, and this is 4-inch. I actually do list this. I know you're like, well, Tyler, it's up on the device schedule. If I'm giving this table, this particular table here to my field crew, I want them to know you got this 4-inch fixture, put a 4-inch hole saw in your tool bag. That's what some of these are helpful for. I also want to mark down the power at maximum so that I know how much that device is going to draw. And then this is where we get clever. This is a unique to PoE Texas thing, but it's our numbering nomenclature that Joe has come up with over many years that he really likes. And this is how he's going to identify the node in the software. The first letter is F, which is the fixture. And you can see I've got a little table down here on the right of different types of things like switches, motion sensors, wall station sensors, and shades. Then we'll put first an identifier. It tells him what type of device he's thinking it's going to be. It's a fixture. Then he gets the room number 100. Then he puts the type of fixture in room 100, which should be type A. Then he identifies which inputs and which outputs he's working with. So in this case, _1 and _2 means Joe is using the outputs 1 and 2 of a link. And then what he'll do is he'll say 3 and 4 are tied to it. And then he uses our MAC address, in particular, the last 4 digits of the MAC address, to identify which link he's going to go to. So you'll notice you've got 00AC, outputs 1 and 2 for 00AC, outputs 3 and 4 for 00AC are all in one link. He's marked them down, and he's kind of associated them together. Now, I've left one blank specifically so you could try out that numbering scheme and fill it out. I can tell you it is an A fixture. So this will be the A fixture. So go ahead and fill this out as the A fixture as you would fill it out using the same nomenclature I used in the first 2 lines. So let's see if I can do it with you. I'm going to put in here. Whoa, that's big. I'd say this is A. And I'm not sure how to make this any smaller. Does this get smaller? So this is A, and then it's going to be 4-inch. And it's going to be, and I apologize, guys, about my writing here, 10 watt. And here comes the complicated one. This is going to be F100A _1_2. And then here I'll put its 1_2 for the outputs. And then I'll say this is on right here, and I'll put this on 0. Now, what I want you to do is take a look. This is a good chance for those of you who are working on Zoom. Joshua should have sent you your MAC address for your device. For those of you, and you could make one up, but for those of you who are actually sitting in the lab, go ahead and open the cardboard colored box and get the last 4 digits, the cardboard colored box, not the white one. Get the last 4 digits off of your link and use those last 4 digits to put here in the field. So it's the cardboard colored one here. And you should be looking for a device that looks like this. It may be black. Some of you guys will have black ones. And then take a look at it. You want these last 4 digits. So if on mine, these last 4 digits are going to be 0E D5. So I'm going to put 0E D5, and that's my identifier. So has everybody been able to find their sticker? And does anybody on Zoom looking at that going, Tyler, I have no idea what you're talking about, what my session number is, or what my MAC address number is? Give everybody a chance to look at that. Now, you could come up with your own practice for this at your own office. You can come up with your own numbering scheme. But what's good about what I'm showing here is this kind of gives you an idea of the kind of elements you want to be considering, excuse me, as you do your numbering scheme. You're going to want to be able to identify things. What this will look like is when you go to program, you'll see this is the numbering scheme we use. It helps you rapidly navigate your programming without a lot of notes. So Peter is saying, I would modify your theme slightly, add a column for input or output type. That's a good suggestion. Then add the I or the O at the end of the code. This would prevent the installer from adding connection to the wrong wires. I think that's a great suggestion. So Joshua, it looks like Daniel would like you to send on his login information. And I think Peter sent his earlier, his email address. So that's a great suggestion. You could add an I or an O. This is by no means an absolutely conclusive, uncontrovertible solution, but it gives you guys the ideas of how you need to start documenting it and why it's important to document. You could also change one thing, instead of just the room number, very often, oops, let me undo that. Very often you will get, you could do, instead of just a room number, this 3-digit code here in there could actually be the fixture number. I've done that before. I like that. And the fixture number is associated with a room. So you'd say all fixtures in room 100 are 101, 102, 103, 102, or all fixtures in room 110 are 111, 112, 113. And that could be very helpful too. And you could redline the drawings. I've done that. I like that. It's by no means like locked down. This isn't the only way you could do it. So now, taking that information, I'd like you to translate it to the next page where we are going to look at your device schedule. See if I can move this dock. This is your power schedule. So take the data and the information. Oh, by the way, and I apologize, I jumped the gun here. I also left the MAC addresses here for the switch. If you look at, I'm going to spotlight this area. If you look at this line, you'll see that I left the MAC address unfilled out. That would also be your same MAC address because you're on the same link. And then you'll notice I also left another one here, this E, which is your light switch. I said you're going to put that light switch on that link, and that would have the same MAC address. And you're going to see that as you go through your programming. So go ahead and take a second to translate what you did on the previous page to this page, because we're going to be working on our very important power schedule. This is now you're going to translate what you did for the PoE and the node schedule into a power schedule. So that this table on the left is all the same stuff you just filled out on your node schedule. Exactly the same information. There's no tricks. There's no differences. But then what you do is take that node name. So get my little highlighter here. I'm going to take my node name, this F100A underscore 1 underscore 2. I'm going to add on the MAC address 00AC. And all three of these node devices, so this one, all of them that have that AC, 00AC, become one node, F100A, 00AC. This becomes one port. And this is the power that I need for it. Can you guys see where I made my mistake? What mistake did I make? Some of these are intentional, some of them are not. I accidentally put it down. Oh, we got somebody from the Q&A. Peter said you may want to add 2 columns to the documentation for the switch and port number to be added later. This will give you end-to-end documentation. Great suggestion, Peter. I agree with that suggestion. You could add columns to this for switching and port number. Now, by the way, Joe and I will send out spreadsheets that we've built based on this information to you after class. So it's kind of the follow-up. You'll get a spreadsheet where Joe's done a much more thorough job documenting it, but I was trying to keep this as simple and as tight as possible for this presentation. So what you'll see is I took the node name, that F100A 00AC, and I put it on our switch, the GBTS 2824, that's the name of our switch, underscore 1 to say switch 1, underscore 1 to say port 1. You'll notice that all my ports are 1. That was a typo. This should be, for example, port 3. This should be port 4. So if I had done it right, what would your, I'm going to put it right here, what would your documentation look like, or what would your node look like? What would you put here, and what would be your power budget, and what would be your PSE port on that schedule? So if I were doing it right, I'm going to say this is F100A underscore 0. In my case, my node is 0E D5. And I don't know why I'm sliding around on the screen like that, but I'll move it over here. Okay. Ian's got a question.
I'm not sure if I'm on the right page or the wrong page, but would your power not be 20 watts at top line?
Ian gets top marks. Ian pointed out that my top line, I said it was 10 watts, but that would be if I had only wired up one light fixture to it. It should be 20. So great work, Ian. You caught my little Easter egg. The power should be 20 on the second column for both item 1 and item 2. And then if I'd numbered it right, this should be GBTS 28-24-M underscore 1 underscore 2 would be the port number I'd put it on. So good catch, Ian. I did do the totals. Did I do the totals? No, I didn't do the totals right either. So that would mean what we're going to do then is once we filled this table all the way out and we know all the power, so this should actually be a 20 here instead of a 10. Your text. So this teach me to do this at 6 in the morning after a trade show.
Just a question.
Yeah, Gary's got a question.
Does the dimming that the color temperature doesn't require any power?
Yeah, well, if you look at the fixture, the maximum, so I'm looking at this light fixture, you have this light fixture on your desk. The maximum output for the fixture in both colors is 10 watts.
So, but the port that feeds the color, that doesn't really have any power. That's just a signal or?
No, the port that's feeding it is feeding the power and the color temperature.
Does it, I guess my question is, does the temperature have a load? Is it a different LED?
Oh,
or
well,
is it the signal?
It is a different LED. So we have, in this case, we have two LEDs. So you've got your 3000 Kelvin LED or 2700 Kelvin LED and 5000 Kelvin LED. They're both on the little LED board on the inside. And when I have full power on this one, it is the cool 5000 Kelvin light. And when I put this guy full power, it's a 2700 Kelvin. So if you're not familiar with the term temperature, and I maybe should have paused, temperature has to do with what color the white light is. And you'll see this in the lab. A 2700 Kelvin fixture looks very orange and kind of warm. The 5000 looks very blue and very cold.
So does the power, can you turn both colors on at once?
The way our fixture is designed, when you turn both colors on at once, it will balance them. So you'd have 5 watts of cool, 5 watts of warm. So you'll never have a total of 20 watts. You can have one warm at 10 watts, you can have cold at 10 watts, or you can have them somewhere in between.
So you need to figure 20?
You would need to figure 20 because you have 2 of these on one link. So 2 10-watt fixtures on one link would give you 20.
Okay, one going this way, one going that.
Yep. So if I had 2 of these, so let's say I'm holding 2, this one is 10 and this one is 10. This can get up to 10, this can get up to 10. They're all on the same link. So they're helping us calculate our total power budget. So based on that, my total power budget for my switch that I'm going to wire up for that room would be 20 watts plus 20 watts, which is 40, plus 40 watts for that bigger fixture, plus 10 watts for the light switch. I should have 82 watts instead of 72. So this is my typo, should be 82 watts. Now there is one other thing I missed on my device, on my port schedule. Can anybody guess what I forgot to add to the port schedule? That's a good question. The wall switch, this WS100 is on there.
Oh, then the switch, this one. Is this taking?
That's on your link. And then I put 3 watts. Those guys are nominal. They really don't draw any power. I forgot the core tap. I didn't add a core tap to this, and I need to give core tap. The core tap is a 15-watt device. So I'll just add a core tap, and it's just 15 watts, and we'll put that on 5. And I'll just put it on here, 1_5 in my notation. Not perfect, guys. Don't sell this to your bosses and say, hey, I did a great job with that. So I would be, in this case, I'm using 5 ports of my 24-port PoE switch. I'm using, and I'm budgeting about 97 total watts compared to, in this case, my total PS 2,160 watts. I think I'm okay. I think, about 100 watts. I'm probably not going to overload that 2,000-watt switch. If I'm right up at that 2,165 watts, I may decide to go ahead and diversify a little bit. But it would be hard considering that's 90 watts per port. All right. So I am running behind on time. This next step you can do if you would like. Basically, the next thing I was just going to say is draw your rack in by freehand. What ports, what wires, mark it up so you can see which devices go to what ports. And this is your racking and stacking example. You're going to need to have a rack and stack design so you know how many switches, how big a rack, what equipment goes into the rack, making sure you give your space some spacing. You'll notice I did not stack everything device to device to device to device. When you're doing lighting, you are using up enough power. You'll probably want to give yourself some spacing in there. So I'll wrap up real quickly. This is during pre-construction. There's one last step that you'll do. During pre-construction, you provide submittals and procurement your materials. This is really important. You submit what you're planning to buy to the architect in an official letter or an email, and you actually get those back as approved before you buy. And that's because you are absolving yourself of responsibility if the architect's like, I want purple, and you put purple up and the owner goes, what the hell is that purple doing up there? And you go, the architect said purple, I submitted on purple, the architect approved purple, you're getting purple fixtures unless you want to pay me to change those out. Now, other lessons learned for pre-construction on planning. Normally, if you're a low voltage guy, very often you're planning on showing up on site after the job is basically done. The paint is up, the walls are in, the doors are in, the carpet's in, all the hammer wielding contractors are gone. When you do PoE lighting, you need to start appearing on site at dry-in. That means the roof is on, the walls are up, and wind and rain isn't blowing into the space, but the carpet isn't in, the walls aren't necessarily in. And what you want to shoot for is when they enclose the server room or they put in the space so you can have a fairly clean, lockable space for your networking hardware. I say lockable. We have actually seen contractors come in, electrical contractors get mad. They'll come in and they'll cut all the networking cabling. I don't know if you've seen that before, but it's happened. But ideally, and that's at worst, at best, you don't want a hammer wielding guy coming in and swinging a hammer near your $1,000 switch and blowing drywall dust into the motors and the fans. So have a door on the IDF or the server room, get it locked, make sure they sweep and clean it, and then get in and start doing your wiring and pulls, because your lights will have to be in either as the ceiling goes up or before they put the ceiling in. And you're going to want to get your wiring in done before that.
Do you have any marking system? So with the drywall, you know where your wires are?
On the marking system, we would.
I put them up, they put the drywall in, I got to reach and grab them.
So Gary's asking the perennial question, if I'm doing a hard ceiling and I put my wiring in first, how do I know where my wiring is? It's a perennial problem that we struggle with. I don't have the easy answer, but usually your field guys will have a good answer about how they mark it. Sometimes they'll just.
We usually use video.
Video is a great suggestion.
Especially near pipes, because whenever there is a leak, equipment is going to be damaged. How far we design it to be away from piping?
That's a great suggestion.
I've seen it, so that's what we do.
Yeah, we're getting a suggestion for video.
And, frame, whenever you do some frame, and then you design away from any piping.
Do the video.
That's great.
Before the drywall goes in?
Yes. When you're pre-wiring, especially when you're on frame, that's what we call it. Once it's on frame, call me when you're on frame. No insulation and nothing, so we can protect wiring and from the.
Take a picture up here.
There's a video for room, same as we're doing here for room. We do it. I mean, if it's just gonna close by, we just try to be away from electrical wires, because sometimes they need to do their work. So, or we elevate them. So according to the code,
That's a great idea.
some cities are required to be high, some higher, away from the electrical.
So a great suggestion for those of you guys at Zoom. They're talking about you video the location and put like distance markers on the video so that you can come and say from this corner on this wall, you go over 5 feet, over 5 feet. That's where the it's going to be. And it also gives you the chance to document you're not next to pipe. And that's a really good suggestion. Peter, and tell me if this is what you raise your hands for, Joshua. Peter asked the question, is there a cooling requirement for the rack BTUs per device? Yes, there is a cooling requirement. These racks do generate heat, just like any piece of network hardware would generate heat. I don't have the number right off the top of my head, but we do have a documented thing that we can give you for the 8-port and the 24-port switch. Basically, it has a minor upsize in your HVAC system. that you would put into a normal server room, but yes, you do need to account for it. And then you need to account for space so that air can flow around them unless you're going to force air in there. But whatever you do, don't like back this thing into a wall and enclose it because it will generate heat and it does get hot. So yes, there is a heating requirement that you need to make sure you deal with. All right, so last step, I've already marked this up. So you can see this is how you would potentially mark a submittal. And I have marked the submittal with everything except the color of this down fixture. So go ahead and just draw a quick circle around what color the architect has selected or you're planning on proposing for this light fixture. It's, I'll get my little markup tool here. I would put my little circle around. Got to move, I got to dock this guy. I would put it around white. Oh, look at that. It's a white fixture. All right, so with that, we've really covered most of the design phase. And now we're shifting into the lab portion of the training.